Welcome to this video tutorial on cryptography in Java. Today, we'll dive deep into the world of cryptography, learn how to use Java for cryptographic operations, and explore how we can keep our data secure. Let's get started. First, let's understand the basics of cryptography. Cryptography is the practice of securing communication and information by transforming it into a format that cannot be easily read by unauthorized users. There are two main types of cryptography: symmetric and asymmetric. Symmetric cryptography uses the same key for both encryption and decryption, while asymmetric cryptography uses a pair of keys, a public key for encryption and a private key for decryption. Now, let's set up our environment. Make sure you have Java installed on your machine. You can download it from the official Oracle website. Also, we will be using an IDE like IntelliJ IDEA or Eclipse to write our Java code. To begin, we'll look at symmetric key encryption. We will use the AES, Advanced Encryption Standard, algorithm for this. In Java, we can utilize the javax.crypto package to perform encryption and decryption. In this example, we generated a symmetric AES key of size 128 bits. Then we encrypted a simple text, "Hello, world." However, be careful. The output of our encrypted text may not be human-readable. Hence, we should encode it using base 64. Next, let's decrypt the encrypted text to show that symmetric key encryption is reversible, given that you have the correct key. Now that we have seen the entire process of symmetric encryption and decryption, it's important to highlight the importance of key management in cryptography. You must ensure that your keys are stored securely and never exposed. Next, let's move on to asymmetric cryptography. The primary advantage of asymmetric encryption is that it allows for secure communication without having to share a secret key. In this example, we will generate a public-private key pair using RSA. In this code, we generated a public-private key pair using RSA and then proceeded to encrypt our text with the public key. Remember, only the private key can decrypt what the public key has encrypted. Next, let's take a moment to discuss hashing. Hashing is another crucial aspect of cryptography that transforms any input data into a fixed-size string of text, which is typically a hexadecimal number. A common hash function is SHA-256. Here we are computing the SHA-256 hash of the string "Hello, world." Hash functions like this are often used for password storage and data integrity checks. They work as a one-way encryption method. Let's cover some critical concepts in cryptography: encryption, decryption, keys, and hashing. Remember that keys must remain confidential. Always use established libraries for cryptographic operations instead of risking your implementation. To further secure our application, it is beneficial to implement additional features, such as secure key storage, using the Java Key Store. Java Key Store allows you to manage cryptographic keys and certificates more securely, and it's highly recommended in real-world applications to avoid hard-coding keys in your source code. While learning cryptography through examples is beneficial, applying cryptography in your projects requires a deep understanding of its principles. Always make sure to keep yourself updated with the latest best practices in cryptography. Now let's conclude the tutorial. Remember to follow the principles of security when designing your applications. The lovely world of cryptography is more than just coding. It requires discipline and constant learning. Thank you for watching. If you enjoyed this tutorial, please give it a thumbs up, subscribe for more content, and turn on notifications to be updated on our latest tutorials. If you have any questions, feel free to leave them in the comments section below.